can see the.
Yeah, but who is going to make this bigger? Yeah, we need to go presentation mode.
Oh yes. Is that this one?
Yeah, but
We're trying to figure it out.
Screen. Yeah, but you see if they need to make it a.
Oh, like a,
I don't know where the
like a full
computer
page,
is.
isn't it?
Do you know where the computer is?
No, not too sure.
Let me just.
Where's the
before I go. Oh, darling, I'll kiss your eyes and lay down on your rug. Just give me some kind after my hug. Be there waiting for you. Know that I'll be there waiting for you. Oh, I'll be there waiting for you. Oh, I'll be there waiting for you.
All right. Last time I was in this room, the lights kept turning off, so let's hope that doesn't happen again this time, and I have better luck. Welcome to the session. Yesterday, I did a session that was called Water Quality Outcomes, and that I said water quality outcomes is my favorite, so this I can't say is my favorite, but this is applied, so that's really good. Industrial stormwater runoff is something that I've done a lot of work in my career, and it's challenging. A lot of people in the room I can see that have worked in the space as well, so that's good. We've got a really good presentation coming up from two staff members from ACH Consulting, Linda Norman, a good friend of mine, and Rudy Nicolas. They're going to be talking about reimagining stormwater discharge from Auckland's waste transfer stations. Linda's a senior designer at ACH, specialising in green civil engineering and stormwater solutions. She's from the US and is a very dear, loving mother to her child, who she talks a lot about, and I talk a lot about my child, so that's a bit of a personal connection. Rudy, he has a strong foundation in land development and surveying with his role at ACH, growing a passion for green infrastructure. He's pursuing a Master's of Professional Engineering. Welcome.
Reimagining stormwater discharge from Auckland's waste transfer stations. More complicated than we thought it was going to be. So, Auckland's aiming for zero waste by 2040. Traditional waste management, aging infrastructure, New Zealand's recent building boom result in a myriad of contaminants coming off these sites. And on the left-hand side, you see the old Waitakere transfer station. On the right, you see Helensville transfer station. So these sites, you get heavy metals, copper, zinc, nickel, mercury, emerging contaminants. We talked a lot about PFAS yesterday, microplastics, pharmaceuticals, and really high organic loading. There's also a lot of risks to these sites. Most of them are in low-lying areas in Helensville's in a floodplain. Waitakere discharges to an estuary and is threatened with coastal inundation. And all these sites have special needs, so to speak. So construction and demolition waste represents about 50% of what goes into landfill. And that's full of arsenic, chromium, and copper, and that gets into the groundwater and contaminates things. So we want to keep that stuff out of landfill. New Zealand disposes of about 50,000 tons a year. of whiteware, and from that we get mercury and other heavy metals plus plastics. The omnipresent polystyrene, it's in the construction material, it's in packaging, it's inside the whiteware, it's everywhere, and it breaks into small pieces, gets into every stormwater inlet, and can clog up the system. And what's worse, on a waste transfer station, when we mix polystyrene with a petrochemical, we get napalm, or something very similar to napalm, highly flammable and very dangerous. And we'll get into that in a little bit. And there's also leachate management. You know the gunk in the bottom of your waste bin? Well, multiply that by every waste bin in West Auckland. Now drive it onto site in a leaky truck, and it gets into the stormwater system. And even in the building where they deposit it, it gets out of the building and back into the stormwater system. So these are diverse sources, and the discarding activities themselves, the traditional way that we dump and run, and we don't want to be at the dump, makes stormwater treatment particularly challenging and makes maintaining the systems challenging. So it's time for a shift in our thinking. Auckland region generates about 1.5 tons of waste a year. Waitakere transfer station handles about 85,000 tons. The high dump volume model is contaminating, on the case of Waitakere transfer station, the Tiwaiaparoa estuary, or Henderson Creek, as you know it. So we need to improve the environmental outcomes, and that requires a shift beyond traditional stormwater treatment. So in comes strategic transition. Thank you, Shane Miller. He was the project manager for Waste Solutions at the time, and he was demanding, particular, and a visionary in terms of this, and that's what we got. So we'll go back. So this is phase one of the transformation, and the white building at the top is the repair shop, and the other two buildings, one is construction and demolition material recovery that can be resold, a door, or you're looking for 40 meters of drain coil, it's in that building. And the other is an op shop where you can buy everything from clothing to furniture to musical instruments to old photographic timers. And if you haven't been there to the tipping point, it's really worth the trip, and they make a good coffee. So this new vision, this is not the right slide. They use the old slides. This is the old slideshow. This is going to be bad. No. All right, I'll try to carry on, but these are not the right slides. So we redesigned the transfer station based on the waste hierarchy. So that means the first instance is reuse, and that's a construction and demolition shop. And in the second instance, there is recycling. So reuse is when we can drop something off and it's used for its original purpose. Recycling, we're turning the water bottle into a stormwater tank, or we're turning the water bottle into a fleece shirt, or we're turning food scraps into compost. So that's reuse, or that's recycling. And then we have recovery, where we can't actually recycle the thing, but we have to recover from it minerals like from whiteware and from e-waste, and that gets processed, and then the rest of that goes to landfill. And then we have dispose. So if we lay out the site according to the waste hierarchy, there's more of a cultural shift for reuse. And that is the first in keeping things out of the wastewater system. Now, I don't know what the rest of these slides are going to look like. This one's the right slide. So you can see here, they've created an inviting space. So it's no longer dump run. You might want to spend time here. You can see how they've used some of the material that normally goes to landfill as the fencing. So the tipping point was phase one. It's the reuse shop. And then we have traffic management. So they redesigned the traffic on the site and the layout of the site. So eventually you go to the reuse first to drop off the stuff that can be reused. So that the last stop is the disposal. So reuse, recycle, disposal. They've also included an education center here to educate the next generation in reducing, in looking at the life cycle of things and buying less. And you might be saying, well, what does this have to do with stormwater treatment? They've done this model in Raglan, and also keeping the recyclable building material undercover keeps it from being disposed of to landfill. So they've done this in Raglan about 20 years ago, and in the first 5 years, 70% of their disposed material that used to go to landfill was not going to landfill. They're now at an 80% reduction every year of what would normally go to landfill. The less in the landfill, the less in the wastewater stream. But we still had to treat the site. And as you can see, it's a beautiful receiving environment, this estuary, once you get past the industrial area. So we divided the site into 8 catchments. One second. There they are. Catchment 1 and 2 are the construction and demolition recovery. Catchment 4 is the big drop-off building. 5 and 6 are the entrance and exits. Those are the catchments we finished. In phase 2, we'll do catchment 3, which is administration and battery recycling. And catchment 3 is all covered areas and the education facility. So out here, we put in vegetated swales, and we mix the mulch in the vegetated swales with crushed seashell to achieve better outcomes in terms of dissolved metal removal. Every catchment that's there has a litter trap in it to capture stuff that makes it past the swales. And then we have a filtera to get some of the dissolved metals and also the finer particles. And there's a proprietary treatment device and a large gross pollutant trap. Those are in catchment 4, which was the most impermeable catchment. It has the drop-off building. It gets the most contaminant loading. But this site had a lot of construction challenges. It's a landfill. It's a capped landfill. It means everything that we put on the site had to be lined. We needed gas monitoring because of the methane and other gases that come out of closed landfill sites. We removed 800 cubic meters of material from the site during construction. It's low-lying because it's in the intertidal, which means all the pipe gradients are flat. They're not self-flushing. Some of the outlets are below mean high water springs. Needed backflow preventers to prevent the water from coming back up the system into the treatment devices, the proprietary treatment devices. And we didn't have the budget to replace the pipes, so we had to make sure the pipes that were there had enough cover to handle heavy traffic loading. Thank you, Manu, because he's out there somewhere. He did the pavement design and struggled with getting the hydraulic head to get the gross pollutant trap to work. And we'll look at the asset performance here. First, we'll look at the surface performance. So the swales, the vegetated swales, and I use the term vegetated lightly here because we had some challenges with the thermal loading and there's 2 more planting rounds to go on this site, are successfully capturing the plastics. And they can be maintained. We're gonna, like I said, we're gonna do 2 more rounds of planting out here. And then at the end of each one is a catch pit with a litter trap in it. And we have a filtera at the very end, but you can see the litter trap here. I don't know if you can see well enough that it is actually capturing the stuff that's making it past the swale. And the beauty of everything being on the surface is the people operating the site can maintain it on a weekly basis. And we met some fantastic people on these sites. They are dedicated. They want to have better environmental outcomes. All they want is a little more knowledge and a little more support from, you know, the team at council who are handling this. So, catchment 4, where the big drop-off building was problematic. That's where we have the cartridges, the proprietary filters, and they kept clogging. And Dutton Stormwater kept clearing them, and they kept clogging. So we started popping manholes. That's the first thing we saw, and we went, oh, great. Polystyrene and petrochemical, because that's what it looks like. Next manhole, a lot of polystyrene. So we got the guys out there to sample the water. Turns out it's the filamentous bacteria that's normal in on-site wastewater treatment. And while it's ideal for your on-site wastewater treatment plant, it is horrible. It sticks to the pipes. It sticks to the media in the filter. It is hard to get rid of. And then we thought, well, it's an old site. Maybe it's a cross-connection with the sewer system. Turns out that all of West Auckland's gooey waste from the bottom of their bin, the liquid goo I talked about, is leaking out of that building and into a cesspit and into the stormwater system. So before we bring the filters back online, we have to put a sump in this building, and we're in the process of doing that, and discharging what comes out of the bottom of the building to trade waste. Because if it keeps going to stormwater system, we're not going to get anywhere. So, but we've had some wins on this site. The volatile organic compounds, the semi-volatile organic compounds, all the petrochemicals below the target values. A lot of the metals below the target values. We have some exceedances, but again, the copper and zinc that are coming off the various catchments, except for catchment 2, where we've put in a new building, we think are coming from the roofs of the old buildings. Also, these are point source samples, so they're not representative of reasonable mixing. If we were to model this for reasonable mixing, it's likely that we're also below the trigger values for 80% protection of marine species. And I believe the next speaker will be talking about that, Leon. So, and here's a quick video. You can see the swales before they were planted, and let's see if that's, there we go. And this is not virtual, this is a real video, it's just really clear. And then you can see on the left-hand side, the little filtera sitting at the edge of the swale, and the old big drop-off building, which will eventually be replaced. And I have one more video. And that is a swale going to our purpose-built rain garden. And if you were wondering, on the right-hand side, you see a little square. That's not anything to do with stormwater. That's the old anchor from when they used to have a big antenna on this site. And there's our rain garden coming up, and the stormwater reuse tanks that supplies the water usage to the tipping point. And Rudy.
Hi everyone. Yeah, so yeah, very good job. You know, that's a hard job. Give us a lot of time and redesign and everything, but we get there. But so following on that momentum, Waste Solution, which is basically the asset owner of all those community recycling center. So they wanted us to kind of like apply the same philosophy in redeveloping the other sites, you know. So as you can see, those sites, they're just pretty dirty, you know. Like, you can see the runoffs, colors, and that's quite bad. So those sites are at the moment in redevelopment. So we've got a site in Helensville and Warkworth where it's basically like we try to apply the same principle of basically just focusing the stormwater runoff into rain gardens to do like basically a treatment at the source, because that's the key at the end of the day. It's really treating the runoff at the source rather than let it go into the rivers and everything. There's another site on Great Barrier Island. This one is interesting because it's actually like a landfill, and then Shane, which was the asset manager for Waste Solutions, he wanted to develop basically a community recycling center like on the same site, literally as the landfill, you know. So we had a bit of a battle with Tonkin and Taylor because they designed the landfill cap, and we were trying to accommodate our community recycling center, but I think at the end that couldn't work for that site. But the idea was to basically trying to kind of like use all the sites from Waste Solution efficiently, And in Whangaparaoa, it's one of the sites I've been working on. So, will it work? Yeah, okay. So Whangaparaoa, that's a community recycling center in Whangaparaoa. So it's mostly kind of like, household kind of like recycling waste. So it's quite a small recycling center, in comparison of the other one. But it's located in a floodplain. So there's quite a lot of issues because obviously the Waste Solution wanted to redevelop the site, and then because we're limited in the floodplain, we got to keep the storage. So we can't really kind of like fill too much, otherwise we reduce the storage. And the issue that we had also with that site is this is an old landfill, so we can't really cut too much neither, So the idea was to basically kind of like trying to basically build up the site, and then excavating a wetland to actually offsetting this storage to accommodate that. So yeah, so the wetland design strategically kind of like located at the bottom of the site. So why a wetland? To be honest, is just we didn't have much choice. We couldn't bring back any stormwater runoff uphill because it's literally like a hole. So the wetland just actually does work really well for us here. It's at the bottom of the site. It's basically just all the stormwater runoff are conveyed toward this wetland, which actually do a treatment before it's actually go into a stream on the site. I don't have any photos of that.
They
the
old slides.
Oh, they?
so I
Okay.
gave them
Sorry,
to
guys.
Joe.
I tried to go to the... Oh, so we don't have any photo at all. Okay, sorry. All right, so I wanted to show you what it does look like. But basically, so the bottom line is, all those sites, they kind of like industrial sites. They, it's very challenging. Stormwaters, runoff from those sites, they're heavily polluted. So the key on those sites is actually to just treat the runoff, like at the source. And obviously, there's different way to treat it, but each site's got their own unique challenge and opportunities to, like in terms of Whangaparaoa, there's an opportunity to create a wetland, like who doesn't want to design a wetland? It's quite a cool project to do. So yeah, all those sites, they're heavily polluted, and then we try to apply as much as possible kind of like treatment on site via natural solution. I think that's your part, no, isn't it?
Yeah.
Blueprint? There you go.
Apologies, they loaded the old slideshow. So, one second, sorry. So, taking what we learned from Waitakere and scaling it to the smaller community sites, Auckland's expanding their network of 21 community recycling centers, taking that and applying it. Keeping as much drainage as possible on the surface, making it easier to maintain, having superior treatment using biofiltration, all that's gonna make a difference. Source control, changing the way people think about waste and reuse, that it's not a dump, that it's actually a community hub where you can go and find that piece of lawn furniture to complete your deck arrangement, and then maybe drop off what can't be recycled or reused. And engaging with the community. We engage with Zero Waste and the Tipping Point people, and there's a whole bunch of social enterprises involved in this, and getting community engagement makes the community feel like they have ownership of that site and they have a vested interest in it. And it's unfortunate that we didn't have the new slide showing the mosaic that we've planned for the Scruffy Dome out at Whangaparaoa, because that's going to be made from old pottery shards that get dropped off, and that'll be done by a local artist. So by being resilient and being a little bit nimble across all the problems that you get on these sites, we can achieve that zero waste by 2040. which is the goal, zero waste really means 80% reduction of stuff going to landfill, which is a lot. And it'll make a big difference in a whole lot of things, not just stormwater. Finally, we'd like to thank Shane Miller, the project manager who was at Auckland Council Waste Solutions, to share in his visionary leadership on redefining these facilities. I'd like to thank Manu from our office for all the difficult and real hard engineering design work. We'd like to thank the guys from Cassidy Construction and Jeremy Laws from EnviroWater for identifying what the goo really was. The team at Morpham for the systematic site sampling, and of course, Kevin and Waynard over at Stormwater 360 for having long discussions about crushed seashell with me. And of course, all the people over at our office at ACH who've contributed to this project.
Thank you. Any questions? Just raise your hands. It's a bit dark in here. Any questions? Okay, I'll kick us off. So any sort of non-structural controls, source control for especially that wind-blown litter? Was there anything sort of site layout or little screens?
So there are screens in every cesspit, and they are in the third section of the site where they're putting those covered sheds. Those haven't been built yet. And that will create some resistance to the windblown litter. But this site is at the concourse, and probably a percentage of it is coming from the neighboring sites. There's a lot of neighboring sites processing stuff. So, and the council has their own gross pollutant trap there that's also getting filled up. So we can put in source controls on our site, but the concourse needs a cultural shift in how it's handled.
I think there's a big reservoir next door and some timber processing. I've been out to that site a few years ago. Okay, any other questions? Okay, we've got a few brave souls. Thank you.
Oh, hi, this is Son from Brother Thomas. Just the air quality in smell, and you're mentioning opening for community use in cafe. That order issue been resolved?
Does it smell at the
The smell.
No, the site is not stinky. The cafe is situated out on the peninsula with the reuse store, and it's actually really pleasant. I really recommend going in there if you're looking for that old piece of vinyl album that you can't find.
Yeah, the odor is actually surprisingly quite contained into the site. It's a good question because actually odor. Oh, sorry. It's a good question because odors is actually more and more of like a nuisance. So surprisingly, those sites are actually the odor is quite contained to the treatment area within the Waitakere site. So yeah, there was not that much smell issue there.
Mike Hanna, Stormwater 360. That filler, the bacteria. Do you know how they manage it at the wastewater plant? Does it have a first flush, or you've diverted it straight to trade waste? I'm curious on is it digested? How do they treat it? How do they manage it?
Normally, that filamentous bacteria is on-site wastewater treatment, and it's actually part of the treatment system. It breaks down. It helps with the nitrogen cycle. And we were told that we could put it to trade waste because those pipes already have high organic loading in them. So it shouldn't affect the hydraulics of the system. The hydraulics of wastewater pipes are not my specialty, but because it's sort of wastewater component, we can dispose of it to the trade waste. I'm not sure I answered your question, Mike.
All right, thank you. A round of applause.
Forwards, backwards. Oh, yeah.
Forwards, backwards. I don't know what that is.
Yeah, so press that one.
Okay, the second talk in this industrial stormwater runoff session, we've got Auckland Council speakers. We've got Leon Blackburn and Martin Meyer. Who'd be an ITA specialist, navigating a lack of discharge standards? Martin's got 9 years' experience within the three waters industry, having worked as a sampling technician, environmental specialist, trade waste investigator, wastewater modeller, and a stormwater and ITA specialist. He's prepared expert evidence and technical assessments for resource consent applications and fast-track applications. He holds a BSc in Physical Geography, Environmental Science from the University of Auckland, and a postgraduate diploma in Science and Technology from Massey University. Leon has worked in the regulatory sector in local government for over 20 years. During this time, he's been involved in numerous site and consent assessments, specialising in industrial and trade activities. Prior to this, Leon produced and implemented environmental management systems for multinational companies based in the UK. He holds a BSc Honours in Ocean Science from the University of Wales and an MSc in Integrated Environmental Studies from the University of Southampton. So please welcome the two speakers.
Thank you. Thank you, Linda and Rudy, for giving us a case study of essentially what we're going to talk to you about. I'm going to try and stick to my notes because I'm going to try and fit 20 years into about 12 minutes. But despite the title, we do have standards, and they implement an objectives and policy framework that is derived from legislation. But please don't make the mistake that we're going to be providing any answers to you guys today. There's probably a whole load more questions that will help us get there as we navigate the RM reforms. So with that, I'll point out, given that I am in the compliance space, that non-compliance with rules in a plan or with a resource consent is a breach of the Resource Management Act and is therefore against the law. But what does that mean for outcomes, and what does that mean given that we are close to 6 years of legislative reform? So we're going to talk about what we've got, where things look like they may go, and what that means for any sort of performance standards that might be assigned to industrial sites and their discharges. So when we talk about industrial sites, we talk about industrial and trade activities, and they are defined both in the unitary plan, and that utilises the definitions of industrial and trade processes under the RMA. But our definition also includes the exclusion of production land, which is something that's actually in the RM definition of industrial and trade premises. So far, so legal. But that's a very suitably broad definition, and it's very inclusive. It uses the word includes, which means that it's not limited to what you're reading on the screen there. And then to further compound that, it says any product or waste material, any intervening storage of raw materials. So that broadness is actually really important for including industrial and trade activities that perhaps we haven't really grouped or covered through an associated risk classification, or as we get new and emerging ones. So the RMA, potentially a friend to many, or an enemy to many more, it is still the operative legislation, and large parts of it are still being pulled through into the new legislation that we're seeing. Key sections for what we're talking about today, regional land use section, and section 15, which is essentially a discharge restriction. It prohibits the discharging of any contaminants, including from industrial and trade activities, unless something else expressly provides for it. So clearly a framework is needed to both provide for the operation of activities and the management of them to meet the overall purpose of the RMA. So we're going to focus on that rule in the regional plan because that is what we've got, and we'll get to the bit that's underlined there in terms of performance standards and infrastructure solutions and what that might mean, as they were an amendment that arose from the Local Government Water Services Repeals and Amendments Act earlier in 2025. One thing to bear in mind, though, is that whilst ITAs might utilise a stormwater network and rain might wash contaminants from a site, it doesn't mean that they are stormwater. It doesn't mean that it has to rain for a site to actively discharge contaminants to the receiving environment. So that said, how do we manage industrial and trade activities? So we have an objectives and policies and rules framework that enables what would otherwise contravene Section 15 of the Act. And these objectives and policies, as well as the general rule framework, was developed under what was the proposed Airland Water Plan back in 2001. And they've been pulled through and further developed into our Auckland Unitary Plan. And that plan has wider water quality objectives that seek to maintain and enhance water quality. And it also has specific objectives and policies that seek to manage the on-site practices of industrial trade activities, initially in a best management practice manner, but also to provide for best practicable option and utilize that approach through an authorization framework. But taking that broad definition, it's also very clear that not all industrial and trade activities are equal, or indeed, even if they are similar, they're not going to be managed equally. So we needed a way of classifying industrial and trade activities based on risk rather than capturing all of them under that broad definition. So Table 3 of our Chapter 33, which is our industrial and trade activity provisions in the Unitary Plan, they seek to do that. And again, that was developed during the time for the Airland Water Plan. And it contains 20 general descriptions and 92 types of industrial or trade activities, classifying them as low, moderate, or high based on the nature and scale of the activity and the associated contaminants of concern. Now, that high-level classification approach presents the gateway to an authorization framework, which is summarized on the slide. And within that rule framework, there's a degree of assumption that if you implement certain provisions and standards as they are written, then there will be an improvement in discharge quality and in that environmental outcome that we're seeking. And to do that, we have both land use standards, so those are sort of the source control aspects, some of which Linda and Rudy highlighted in their talk. But then we also have a discharge standard as well. And because of the uniqueness of each industrial and trade activity and also the sites that we deal with, the industry generally leans very hard on the best practicable option. And just because something is low or moderate risk, it doesn't mean that they're not going to discharge contaminants. Again, we talk about if they're badly managed, there might be quirks to the site. But you'll also notice I've added the word unlisted in that table. And that's basically there to accommodate those industrial and trade activities that quite literally are not listed in Table 3. So it allows us to default back to that overarching definition. So a level of assessment is always going to be required, and that's fairly straightforward in terms of the land use provisions for source control and the structures that are required, for example, the bunding of environmentally hazardous substances. So that table there summarizes the general standards. And like I said, the land use standards are based on a best practice approach. And the moment we start moving into a best practicable option, i.e. they're not able to implement those things, we're opening up the potential for human control of that and the potential for discharging increases. And so that's where we might be seeking the need to require consent. If you're a high-risk site, then that table essentially deems that it doesn't really much matter how well you manage the site. There is some increased level of discharge or effect from the site. And so the structure of the rule framework is there that all high-risk activities require some form of authorization through the ITA rules. But in saying that, what does a complying discharge actually look like? That's the bit that we're focusing on today. So if you think of one of the slides around the trigger values in 80% ANZAC in Linda and Rudy's talk, what does that mean? So that's what we're going to eventually get to, hopefully, through this. So there's a gap in that understanding as to the level of treatment that might be required to actually mitigate those discharges to an appropriate level. Frankly, an improvement resulting from the site simply cleaning up and being slightly managed better and then labeling that as BPO is a pretty low bar. And so accepting that acceptable level of discharge, the treatment required to achieve it requires an understanding of that site and its operations, the contaminants of concern, and then also the capacity of the receiving environment to accept a determined level or a level of that discharge. So essentially, that oversight for the appropriateness of operational and structural controls is required, and that includes treatment devices for their ongoing operation and maintenance. On top of that, we typically add sampling conditions so that we can track improvements and understand trends and confirm whether the choices that were made were correct. At this point, though, all parties are requiring a degree of certainty that the outcome, as per the wider objectives and policies, is actually being met. It shouldn't need to be an ongoing discussion with the site along the lines of how well are we doing, what else do we need to do, are we compliant? And Martin will take you through some case studies.
Thank you, Leon. So, everyone now knows exactly what an ITA is, right? First and foremost, how are we going to determine if discharge complies in the real world? So in case study 1, we're looking at those big established operators of a well-understood, large-scale, high-risk process, discharging, in this case, to a coastal environment. This site was up for a consent renewal, and the type of industrial site where the current regime, being a guideline for discharges, is well-suited. The site has long data sets already, both within and of the discharges from the site, and you can, with this data, create well-defined trigger limits for site management and consent limits. The site uses trigger limits then to understand how discharges might be varying and where they may need to improve. For this historic site, it's advantaged in that way. They can be assured that through continuing their process and known discharge values, that they're likely to continue to meet and be below trigger limits. So no surprise structural works or adaptive management requirements will occur unless there is an exceedance. Council is equally assured through this historic data set and the trigger limits that the discharges are appropriate for the activity and the receiving environment with regard to the guidelines, and that, if must, adaptive works can occur. However, what would a regime change look like for this sort of site? Predetermined discharge limits. They could be set at a level that the site would struggle to meet. Would the site become permanently non-complying in that type of regime? But on the contrary, if it's something too easy to achieve, i.e. a higher discharge limit, would they still have less than minor effects on the receiving environment? What would the consent holder look, would they look to relax their maintenance if they were already meeting that predetermined threshold? Would it require, would they potentially be decreasing the quality of the receiving environment with that type of regime? So with that in mind, we move on to case study 2. In this case, we have happened to tie up with what Linda was talking about, but in general, it could be any sort of smaller scale site up for renewal or perhaps being caught under some monitoring of industrial sites. This is, again, a sort of a well-known activity, and we are, in general, happy with the business best practice treatment proposed through structural and procedural controls, as Linda referred to. This will be required through their ITA consent. So this could be bunding, gross pollutant traps, biofiltration, filtration devices. As Linda talked about it at their site, I mean, it was a real treatment train, and it's sort of a standard procedure for these sorts of sites. Council and conditioning these sorts of devices are confident that the controls are appropriate, based on evidence from other recycling facilities within the region where the activity is sort of comparable in scale. While total discharge of contaminants may not be known accurately until sampling is established, the greatest unknown is quite often the sensitivity of the receiving environment, where there's very little data. In general, where council is consenting a known activity like those typically found in Table 3 that Leon referred to, it can be expected that improvements will occur to the site, and over 2 to 3 years of sampling, we can establish trigger limits. But that leads us to the most disadvantaged activity under the current regime, case study 3. And this is for new and novel activities. New activities present a real challenge under the existing framework. A cautious approach in line with the precautionary principle that's afforded under the RMA is often taken by the Council. This approach might be seen as excessive and as a barrier to entry by the operator, as new activities are often carried out on pilot sites or proof of concept and commercial viability. Atypical, they represent a real challenge for the ITA specialist in determining what the adverse effects will be on the environment. As with case study 2, there's typically a lack of data available at the get-go on the discharge and on the receiving environment sensitivity. Unlike case study 2, however, there's no sort of comparable sites for us to know whether or not the proposed controls are appropriate, and there's no best management practice for a novel activity. So this is one of those sites we'd call unlisted, as Leon referred to, not within that table. So there remains a lot of uncertainty as to the level of treatment that might be required for this type of site and to mitigate the unknown adverse effects on the environment. Is it still less than minor, the effects on the environment? So if we have a site and we're unsure of what the discharge will be, how does the current regime play out? If the ITA specialist is assured that for the contaminants involved, the controls are the best practicable option, through the data supplied, be that overseas or otherwise, then as with case study 2, you still need 2 to 3 years of sampling to create some sort of trigger levels for the site. There's a risk for the business through this as well. It's not certain that the structures that have been provided will meet those limits. If exceedances are found to occur, then you can lead to a costly outcome for the business. Alterations may need to occur, new structural controls, some management changes, management of these controls. In the meantime, over this 2 to 3 years of sampling, there may have been excess contaminant discharge occurring to the environment, which is not what we're about. You know, we don't want to degrade the receiving environment further than it currently was, hence that sort of precautionary approach from Council for these sorts of activities. So is there a possibility here on a predetermined discharge limit, and what would it look like for this case? Council would have immediate assurance if the limits are met. You could sample it and know straight away whether or not it's compliant or non-compliant. If not, the applicant can mitigate further through adaptive works till they meet this required limit. This still places a burden, obviously, on the applicant, but through due diligence and assurance of a fixed limit, applicants prior to making the application for consent can, through pollutant modelling or further investigation, design a system that will meet this particular limit. If they're able to undertake the work prior to establishing their activity, they can be assured they'll be meeting this fixed discharge limit if that was to be the new regime, and be less dependent on the discretion of an ITA specialist who will be assured there's a method that's been undertaken to sufficiently mitigate the risks to the receiving environment. Discharge limits would further encourage operators to provide data on the expected quantity and concentration of discharge of contaminants expected from their sites. So this could lead to some sort of encouragement within the industry of some more standardised treatment systems, which would also be a positive. Moving back to Leon.
So, brave new world of RM reform. We've already had indications through national instruments as to the direction being taken for national consistency through national policy statements, through the reliance or the more reliance on national policy statements and national environmental standards and national environmental performance standards. So earlier in the week, Tamara Alawai held a workshop with regards to the stormwater, national environmental performance standards for stormwater. And we already have the wastewater versions upon us in various states of operativeness. And if we think about the wastewater performance standards at the moment for treatment plants and their discharges to water, at the risk of simplifying that approach, those standards, they qualify the receiving environment based on 5 or 6 categories without fully accounting for the specific quality of the receiving environment that will be receiving that wastewater. They don't get individually assessed, and the standard is only applied to a certain number of parameters, with no scope to change that within that framework. And we know that to a certain extent, wastewater systems, they are a closed network. Treatment plants are a known technology. And generally, we're aware and know about the treatment efficiency that can be achieved. And if we apply those same principles to stormwater, or stormwater networks in particular, even though I said ITAs are not stormwater, they do utilize that network. If we follow those same principles and pre-classify the environments, we'd also be needing to pre-classify the contaminants, and the levels would then be predetermined as Martin has discussed. So again, ITAs are not stormwater. They don't necessarily need to use the network to discharge contaminants to a receiving environment, and they certainly don't need it to rain in order for them to be discharging in an active capacity. So would they come under these performance standards? If they do, then there is that potential for a conflict in a tiered regulatory system based on the location of a site and whether that site is discharging to a network or not. So what are the implications for this? It's pretty clear that for industrial and trade activities, one size does not fit all, and that there is a degree of assumed performance, both through our standards and also through when we consent an activity. And potentially that is a low bar if we are seeking environmental outcomes. We have state of the environment data that indicates we are still getting declining water quality in our urban environment. Not all of that is going to be linked to industrial sites, but a significant proportion of it will be. Further, under the reforms, regional councils are going to be held to achieving environmental limits, and that is going to be impacted by third-party compliance as well as national performance standards, especially if those performance standards get set too low to achieve those environmental limits. And how would you go about applying that to second and third parties? How do you do that equitably, knowing that the requirements and costs for a site could change as a quirk of the location, connection to a network? And also the costs of ongoing sampling. Would an ongoing degree of assumed performance be required? If you're sampling weekly, that's a significant cost. So you have to move to some form of assumed performance for the site. So we need to be very careful about what activities you would pull into any stormwater or an associated environmental performance standard for discharges of this nature. On its face, there would appear to still be the need for a degree of flexibility and individuality in developing any form of discharge standard to account for the quirks of a particular site, in addition to those overall outcomes sought. Now, in an attempt at some form of answer, which I said we weren't going to do, it might mean that we have to look at catchments more holistically, not dissimilar to attributes under the NPSFM, and then decide what interventions are required to achieve the outcome that we want for that catchment, for the water quality in that catchment. And that might mean that you look at an industrial area, understand the risks and the activities that are going on there, and then see what can be done without those excessive costs necessarily being borne by each of those individual sites. That's not to say that they shouldn't bear some cost. They are, after all, utilising a capacity within the environment that they should pay for. But that's one potential option of how things might be able to play out and utilise a performance standard to accommodate the quirks of industrial sites. And with that, maybe, there we go. Any questions?
Thank you. A round of applause, please.
Left too long.
Yeah, you've got 7 minutes for questions.
Don't tell them that.
You've got 2 minutes for questions.
Rob doesn't have a question.
Any questions? Yes, Rob.
Rob Vanderbank of Tonkin and Taylor. I don't know who would want to be an ITA specialist. I guess there's a couple of questions that sit behind kind of what you've just talked about, and one is a bit of the history of why we're sampling and where that's come from, and whether or not there's been a shift in the purpose without us actually realising. So, I've been doing this, more than 20 years in this space. And when we first started, it was around the identification indication that the ITA sites have heavy contaminant loads, and therefore the level of maintenance on devices was significantly more than what you would normally have for a default stormwater treatment device. And so therefore the monitoring was to identify what an appropriate monitoring frequency was. We've now kind of moved on and now using the monitoring to actually evaluate the effects. But the same problems that were there from day one around monitoring stormwater is really, really hard. Capturing the right storm event, the right time of the storm event, all of those challenges are still there. But if we're trying to understand what that environmental impact is and whether or not we need to have a great level of control or not, do we need to shift the approach? And is monitoring the right approach, or would we look at something like an environmental risk assessment type approach, which is used overseas, to understand that risk and therefore whether or not a greater level of control and monitoring might be suitable?
Yeah, I think that that's probably going to have to be part of the response to get into that space and get the outcomes that we seek. And certainly that's definitely been the move in terms of that monitoring. And as monitoring officers, we know that there's that degree of flexibility, that we are trying to understand what the site is doing. It is still about, okay, you've got a couple of peaks here, what happened? Are you maintaining, are you still doing your source controls? And I think that that's still very valuable. It works really well, but I think that probably does shift it into that improvement over time, which is obviously better than nothing. And that's why I made the comment that perhaps that holistic approach on that catchment front is the way to do that. And I think that would accommodate that risk approach that you've just outlined, because you are saying, right, you've put in things that work. Again, they're stormwater devices, right? They have a role for stormwater, but that loading and those contaminants of concern, is it the right one in the right place for the right outcome? And so I think that you can definitely scope that, even within the structure and the framework that we have. But I think that you're right, that risk profiling, accepting that, okay, you've improved and you're not really what would be ideal, but that improvement is significant and is a step towards those overall outcomes that we're seeking.
Hi Leon, hi Martin, Abby from Auckland Transport, and ex-ITA specialist. So Rob, there are some ex-ITA specialists sitting here in this room. With the theme of the Stormwater Conference being Te Mana o Te Wai, there has been, in the past, I don't know if it has progressed further, about enforcement actions, and we've seen quite a lot of need for it in the past. So I just wanted to understand from your end, have we progressed in that space, if there has been any breach of non-conformance, and how are we progressing enforcement actions to ensure that we don't have repetitive offenders in terms of moving forward to discharge of contaminants into the receiving environment? Thank you.
I presented on that last year. No, absolutely, and I suppose that's one of the things in terms of being able to undertake a form of compliance or enforcement action on a discharge. You kind of need the limit, but somewhat conveniently, if someone is breaching that, they're not implementing or doing the things they said they were going to do anyway. So from a compliance perspective, that still works as a breach of consent, of a consent condition. And the regional councils and district councils have been afforded a number of tools under the RMA, but generally New Zealand has kind of erred away from doing compliance. People are trying to do the right thing, so that's good enough. And generally it is. People who want to do the right thing will. But we have, over the last 2 to 3 years, been utilising the enforcement tools available to us. So, like I say, it's difficult on the discharge space because there isn't a preset number within the consent. But going back through the implementation of structural controls, operation and maintenance of devices and the like, that's the opportunity for the compliance angle that we can take at the moment. Of course, shy of a catastrophic incident and a huge discharge, which does make it a bit easier. But those cumulative discharges is still difficult to put into a compliance framework without those standards or those limits.
Do we have an ITA wrap loading for next year? I think the main thing here, though, is, you know, specialists. You've got ITA specialists there. Now, you need specialists, I think. You need somebody with good chemistry knowledge, good civil engineering and mechanical engineering knowledge, typically for these sorts of projects. I worked on a site where zinc discharge was just excessively exceeding discharge consent limits, and you know, the roof was repainted, the roof was replaced, but take a step back, there's a big fertilizer plant next door with a big hopper,
Yeah.
and the dust is coming over the hill. So exactly, look at the neighbours. You know, we heard litter
And I think
coming
that's a
over
really important point as well, because it's all very well us being specialist consultants, planners, etc., but you've got a guy who's used to dismantling cars. So how do you convey to them as well what it is that they need to do to, you know, they've spent money on doing this. So how do you convey that message to them on an ongoing basis as well?
Last question here.
Jim Linhart, I'm from the States. I've been involved in stormwater monitoring, setting up regulatory processes for close to 30 years, including the state of Washington and New Jersey and a few other places. U.S. is also involved with setting up a national program called STEP, which is a fairly structured monitoring and verification program. And then ASTM has set up a committee on stormwater control measures. So rather than reinventing the wheel, do you consider kind of collaborating with what's been going on in the U.S. for a long, long time? And trust me, it's not perfect, but made a lot of progress over time.
Yeah, I mean, it's still water, it's still water quality, so the principles certainly apply. So yeah, I think that there's a lot of opportunity for not reinventing the wheel and applying it and those kind of knowledges. Yeah.
All right, round of applause, please. Thank you. All right, we're going to break for some refreshments now downstairs, so please head down that way. But if anybody's got good talks like this for next year, please, we need more water quality and industrial stormwater runoff talks. So thank you all.